So example 6 of our variation notes says, find the constant of variation and the variation equation. So we have this statement here of P varies directly as T. So that's going to be P is equal to K times T. And inversely as the square root. So inversely, so it's going to put it in the denominator as the square root of V. So square root looks like this of V. So I'm going to put that there. Then in order to find it, we're going to need to do some substituting. So we know that P is 10. So I'm going to put a 10. And then K times T is 2. So times 2. Over V is 25, so I have the square root of 25. So I ran out of room, so I'm going to come over here and say that 10 is equal to 2K over square root of 25 is 5. So to solve it for K, I need to multiply, so I get 50 is equal to 2K, and then divide by 2, and I get that 50 divided by 2 is 25. So this is my constant of variation right here. And then I'm going to have to put it into this. I need to put that K in for this problem, and I get that P is equal to 25T divided by the square root of V. And this is my equation of variation right there. All right, so we say that we have several things going on here. So we might say that Y varies jointly. So there's kind of several things happening. So if you do see Y varies jointly with M and N, it means that Y is equal to K and times M times N. So times both of those. So jointly. So 7, Y varies jointly as S and T and inversely as U. So when I set that up, I have an R, so start there. It varies jointly, so there's equal K times ST, so ST, and then inversely as U, so it's going to be over U. So there's my yellow. Pink, R is 18, so 18 is equal to K, and then S is 2 and T is 3 over U, which is 4. So you can do this and solve this any way you want to. You might multiply 4 times 18 and get 72 is equal to 6. Okay, so 2 times 3 is 6. And then finish that up and divide both sides by 6 and get 12. So 12 is equal to K. So from there, I'm going to substitute it back into my original. So my equation of variation is going to be R equals 12ST divided by U. So now I'm ready for this blue statement here. And I'm going to plug that in and say, see, R is given as 6. 12, S is not given, but T is 2, so I'm going to put 12 times 2 times S over, and then U is 4. So we need to solve that. Let's see what we got. So we have 6. I have 12 times 2, which is 24, S over 4. So 6 is equal to 24 divided by 4 is 6. So 6S. And so that means that S is equal to 1. I kind of ran out of room. I wasted it there, didn't I? Example 4 has got a lot of words, and it's not easy, but I just want you to see that even though it looks complicated, that that you can work through these problems that say the words varies directly in them. So at the volume of gas, so V, I'm going to call volume, of a given mass varies directly, so equals K times, its absolute temperature, so I'm going to use T for temperature, and inversely as its pressure. So it's inversely, it's going to be over it. Then the pink section here, I got 2 degrees centigrade, so I can figure out that that's my temperature, 2, and a pressure of 99, they say it right there, of helium occupies 23. It says the 4 grams of helium, so this is actually what is the given mass. So that's my given mass right there, and this is going to be the volume right here, and the number of liters is the volume, so it's equal to 23.1. So now I need to solve that for K, so I'm going to multiply by 99 and get 2286.9 is equal to 2K. And then I'm going to divide by 2 and get 1143.45. So here is my constant of variation. So I'm going to fill that in. So the volume then is equal to 1143.45 T divided by P. So this is going to be my equation of variation for this situation. And now my blue section, I'm going to come in and answer that final question right there and put in that what is the volume. So I'm looking for the volume of the helium. So I'm going to have 143.45 times the temperature, which is 27, divided by its volume, just a pressure, divided by its pressure, which is 121. So I'm going to put that in my calculator and come up with 255.15, and that's volume, so it is liters. And that's going to be my final answer. All right, see you in class next time.